So without taking much more time, I'd like to get started with the first speaker. The first speaker comes with a background of doing work in R&D center, business development. He has worked in innovations in industrial digitizations, machine learning, data optimizations, advanced human-machine interactions. When I got hold of him a few times, short sessions, I said, do you have any questions for me or anything? He says, no, anything and everything is fine. On this topic, I know it all. So folks, without much ado, let's welcome Mercy Zhang, Vice President Subcon, for the first session. Please give him a hand. Mercy, over to you.
Thank you, Vikram. And it's super nice to be here to get this chance to share with you our who are we first, and what we are doing, how we are harnessing AI to help process industry. So first, Subcon, we are a process automation and digitalization vendor founded in 1993 in China. And earlier this year, actually 2 months before, we refreshed our mission to leading industrial AI to sustainable growth, because we truly believe that this trend of AI, maybe now we're talking too much about it. Everybody's AI every day, but it's going to be the next big thing. And especially for us, for process people, for control people, we need to take serious about it, because it truly can transform how we operate, optimize our assets. So back to the topic. So where are we exactly in the whole landscape of digital transformation? Of course, we already skipped the first curve, purely using electronic things to try to automate the workflow, to try to replace the human labor as much as we can. But still, digital transformation itself is still a big, quite vague concept. Everybody is talking about it, but we are not 100% sure what it is. Now, combined with AI, is getting a bit more complicated. But everybody here, everybody in this industry knows it is the future. It can bring true value to us, and it is a must-have. It's not a luxury to us. So there is no doubt on this part, and we see a lot of investments into this certain and definite investment into this area. So as a vendor, so for our point of view and our decision under this circumstances to invest 100%, 150% we got to develop next generation digitalization and AI solutions for the process, not only automation. So here are the technologies under this point of time. The technologies is truly fascinating the whole industry. A lot of buzzwords, to be honest. IoT, cloud, big data, and robotics, you name it. We all know it's important. It is very important. It's essential for us to get there, the digitalization version of us, right? So how to utilize this, how to really get value out of it has been a very, very important topic for years also. So at this trend, after the ChatGPT thing, after the large language model get into everybody's life, these different domains of technologies are getting more important. And how to, even if we want to get value out of one of it, we need to work with all of it. For example, if we want to do linear regression to predict the future value of our tag, you need an infrastructure to run your Python code. You need your runtime to run your software, and absolutely you need to convey the signal, and you need actuator that is modernized enough to receive the signals. So AI and digital transformation is getting to be a more systematic engineering work. So it's becoming one whole thing rather than scattered out different concepts. And everybody in this room, I think we are all, in our organization, we're definitely already investing, developing, and researching the latest technologies, the toolbox we showed in the last page. And we are on the way, try to manage them together to truly put our talents to focus on them, to understand how to let them work together. So back to the industrial AI a bit. What it is, industrial AI? So quote from Paris, Professor Paris RS, industrial AI is a system engineering work. So it combines not only machine learning, not only reinforcement learning, big data, cloud, also traditional OT world things, for example, the PLC, the DCS, the transmitters, robotics. So everything combined together, fabricated by best engineers, come up with a framework and put it into production. That is industrial AI. Without one single loop in the middle, you won't be able to get any value out of it. So if you have one, let's say maybe a background in machine learning like me, send me to a refinery plant, I can't do nothing without any experts to guide me to how to utilize my knowledge and the Python script I wrote. So it is important to keep in mind that industrial AI is truly a system engineering work. And talking about AI, so what is the difference between now and past? Because we, as people from OT and control and industrial, basically we invented the idea of artificial intelligence. So what changed now? I think most important point is the way of thinking is changed. Like, for example, what truly runs our asset, our plant, is all based on first principles. We need to basically compute. We need to basically control and compute everything. We need to understand underlying principles and rules. So then we come up with our traditional tools like PID and MPC, simulation software for dynamic and static states. And now we still have a lot of areas, critical processes, that it is very intrinsically very hard to understand. So the frontier of human science cannot reach there. For example, some process in refinery, we cannot simulate it because it's too complicated. And now we have a new tool that is data-driven method. Without understanding the underlying principles, we still can come up with solutions. We approximate it. Although we cannot get 100% accurate answer or 100% accurate way of doing things, but still we can approximate the right path. So that is data-driven. Without full discovery of the underlying principle, but still we can solve very, very complex and valuable questions. So that's intrinsically the basic difference of the two ways of thinking, data-driven and first principles. And to adopt the data-driven way of thinking, to adopt industrial AI, you have to adopt the data. And as we can see, the top use cases related to industrial AI, where you can imagine how massive the data underlying those domains, discrete events, the time series data logged in our historians, and objects stored in our cloud infrastructures. So those are the foods of AI, per our founder said. You need to utilize, organize those data, and gather those data together to feed your AI to train it. So that's the very starting point and most essential job if we want to implement or develop industrial AI use cases. So, but data governance or how to digest those data, it is a very complex topic by itself. So for years, we developed big data pipeline. Even in industrial field, we have our industrial version of big data. We see time series database. We see traditional real-time and historian databases. We already working in this field for so many years, but still, it is very complex. So we believe to get next generation industrial AI. First, we need to build the next generation data infra to build it again, to reinvent it. So our approach is we focus on one domain, because you cannot suddenly invent a holy grail to cover all the aspects of our daily life. So we focus in process industry. We see which domain of data or vertical of data is truly valuable, necessary for operating your process asset. So first, definitely the process data coming from our control system and sensors, and then equipment data, like the health status of your transmitter, or maybe a card, a status of your card in your CIS or DCS system or PLC system. And then the laboratory result, very necessary to define if our product is in good health, does it need any improvement. And then the design data, which at the very beginning, when we want to set up a process plan, we need to design it in a simulation software. And when we're trying to improve the process, we need to redesign it in the software. So we gather these 4 domains of data together and orchestrate it, contextualize it, and then feed it to like domain purpose AI. So that is our belief, how to streamline the industrial data operation. And then after we get the data, we need to train basically a black box AI, right? So in an arbitrary way, we can, nowadays we can divide AI, the modality of AI into 3 ways. First one, the popular one, large language model. Everybody knows it. And then CV is computer vision model. I would say that is the most practical and valuable modality currently we have. And then the time series models, like those models we learned in our maybe undergraduate degree, how to predict the future of stock market, how to predict the failure of a critical asset. So those are based on time series regression or forecasting. So those 3 modalities are the main topic we have when we're talking about industrial AI nowadays. So today I want to emphasize on one of them, that is time series prediction. Because in process industry, like 90% of our daily operation can be represented by time series data, obviously. And in the past 2-3 years, the big advance of AI and this trend of LLM is mainly focusing on the NLP side. It's not on the time series side. But we can truly borrow their idea and backbone and the result and even read through the articles to try to replicate this success into time series world. So actually, that's what we did. We invented a deep neural network based on transformer, but not to predict the token, to predict the future of time series value. So we call it time series pre-trained transformer. And it is dedicated for predicting the future status and future tag value of complex process industry process. I'll give you a quick example. A very complex process. In the past, the pain point of us in this industry is first how to improve the quality and yield, definitely, and then how to reserve the special material used in this process. By first principle method, it is basically we can't achieve good results, but it caps there because some of the value we cannot resolve. We cannot compute out of first principle because simply we don't understand the underlying rules. But now, based on historical data, within 2 months and 1 billion parameter transformer AI algorithm, we can achieve very good result, better than first principle, better than dynamic simulation purely. And we implement the future result. How do we implement the future result? We observe the future status. If that is favorable, then we come up with a control tactic based on reinforcement learning and let simulation software and our domain experts to examine it and then implement the method into the closed loop. So that means the whole thing, the whole process is very robust. There's nothing unsafe here. So that is one example where how we're using time series prediction, data-driven method to optimize our process. And then generative AI. So although the last example is kind of already a generative AI example, but now we already don't have a rigorous mathematical definition of Gen AI. When we're talking about Gen AI, we're basically talking about how we build extraordinary things based on large language model. And there's no doubt everybody knows it. It's very popular and it's growing at an extraordinary rate. So how can we use Gen AI in our operation? Since it's mainly a large language model driven thing, how can we adapt it? Just chatbot? Not at all. Actually, because there are so many things can be represented by text. So that means we can use large language model and Gen AI in a lot of aspects throughout this value chain of our daily operation. So a quick example would be, actually I think this one is the most intuitive one, to generate code. For us, for OT engineers, that would be ST code. For IT engineer, maybe Python or JavaScript or Java, things like that. Because coding language is language. It can be easily recognized and digested by large language model. And then LLM, which is Gen AI, can generate things that is, the quality is literally higher than outcome from a human engineer. So that is a very popular use case and robust use case nowadays. And actually, we use this in our next generation control system, UCS, to generate ST codes for our engineers. And then another example would be using generative AI to generate applications. Apart from the time series data, we have a lot of data called transactional data, which relates to the application we use daily on ERP, on human resource, on supply chain. Those data are basically related to we place an order, we hire a new talent, or we make some decisions. So these are called discrete events. So all those discrete events can also be represented by text in some manner, some technical details behind, just like in the morning session. This way of representing discrete event to language is called agent nowadays. And just you can see here, you can use natural language to generate database schema and generate front-end interfaces, human-machine interfaces. So this is beyond just predicting the future value or generate programming language. With this demo, you can imagine large language model can literally generate a software, so generate an application for transactional data. So this kind of use case got huge potential in the future if we got the right data, absolutely. And then chatbot is also a good thing, to be honest. And one of our most important customer loves chatbot because it really helps them to organize the knowledge. I'll throw a quick example also. Like in the past, if we want to draw up a SOP out of our platform or maybe our Google Drive, you name it, any storage material. So you need to know exactly the file name to search for it. And then we got model searching. And now we got AI engine-powered searching. That means you can basically throw out your question. For me, maybe I'm an operator. I don't know how to deal with this, let's say a transmitter. I just throw out the question to the system, and the system is going to come back me with a PDF, or the right PDF file, or even extract information from the PDF file and illustrate it directly to me. And this is truly useful and helpful. And this one is truly, I would say, easier to implement and easier to get value out of. So apparently the chatbot is actually the most popular and most, for now, the most valuable use case for industrial AI. So I showed several demos, and those demos are actually already implemented in our customers, end users' plant. I would say throughout the journey is not a very easy thing to even build up this kind of POC or validate, even just validate the value of AI. So why is that? Why is that it is hard for us to, we're talking about AI every day, but it is really hard to get it working in our complex organization. Because back to the very beginning point, it's a system engineering work. It's fairly complex, and need a whole team of best engineers for different domains to work together toward one target. So that is something we often oversee. So we need to come up with a strategy to implement any kinds of industrial AI use cases. For example, starting from the infrastructure, without in OPAS concept, without a ACP, how can we run our Python code in the control, in the L0, L1, L2 environment? It is simply not possible. We need a modern compute infrastructure to run the code, to do the inference. And without a robust and fairly high-frequency communication method, how can we get high-fidelity data? Again, it is impossible without UA or UA companion spec. And above the layers, there are more questions to be answered. Before we implement any industrial AI use case, we need to identify those questions for our organization and to first plan how to solve those questions one by one or simultaneously. But one thing to keep in mind is that industrial AI is not a machine learning engineer's job. It's everybody's job. And we need to get a whole team of good engineers with different knowledge to work together to achieve the use case. I believe in the future, maybe this will change because now when we're using iPhone, it's a fairly mature industry smartphone. We just put it out and then we can call whoever we want. It's fairly easy. It's a black box. It don't have so many complexity. I believe in the future, AI also will be like that. Maybe it's going to be a smart PLC or software-based control system in our computing infrastructure. We just open up the human-machine interface, just like we open up Microsoft softwares. And we just do some clicks, and then our plant can be magically optimized. I believe this is going to be the future. But now, we need to do it step by step. We need to be very practical and respect every technical detail. Thank you. That's all I got for you.